In this video, I'm going to teach you about proportions. A proportion is an equation stating that two ratios are equal. That means that one ratio has to be equal to the other ratio in order for it to be a proportion. So there are three ways to tell if they are equal. The first way is to cross multiply. And you do this with smaller numbers only. This is where you go 7 times 8 is 56. 30 times 2, that's not 56. That is 60, and so they are not equal. They do not form a proportion. Let's check out the next one. 6 times 4, 24. 5 times 5, 25, and therefore not a proportion again. They are not equal. What about this one? 2 times 4 is 8. 8 times 1 is 8, and therefore, yes, these are equal. That makes sense because 1/2 does equal 4 out of 8. Remember, you should be taking notes on your own notes page at the same time as watching this video. When we get to larger numbers, it's not as easy to cross multiply because you're not using a calculator, most of you. And so you can reduce these fractions. The sneaky devil goes into 15 and 21. So if I divide both of these by 3, 15 divided by 3 is 5. 21 divided by 3 is 7. Let's reduce on this side. 5 goes into both of those. 25 divided by 5 is 5. 35 divided by 5 is 7, and therefore these are equal. I'm going to hop around for a second because this one here looks kind of scary. Those are improper. And even though we will do it, we're not going to do it yet. Let's go on to this one. Those look not too bad. These are both improper. Well, 5/12 is already reduced, so that one just stays. I know that 15 and 36 can both be divided by 3. The sneaky devil again. This would be 5. 15 divided by 3 is 5, and 36 divided by 3 is 12. Guess what? They are equal, and this is a yes. These two ratios do form a proportion. Okay, now I think we're ready to tackle the bigger ones. Let's go to this one here. Well, I know that 20 over 4 equals 5 because a fraction bar means divide, and 20 divided by 4 is 5. 17 divided by 3, though, would be 5 and 2/3 left over. Therefore, no, these do not form a proportion. Let's try these up here now. I think we're ready to tackle them. Let's just reduce them. Instead of making them into improper or mixed because they're improper, we could just reduce them. Let's divide both of these by 3 and see what happens. 24 divided by 3 is 8, and 15 divided by 3 is 5. Now these over here are both even, so we could divide both of these by 2. I have room on this side to work, so I'll show my work. 16 divided by 2 is 8. And 10 divided by 2 is 5. Therefore, 8/5 on the left, 8/5 on the right, and yes, these form a proportion. That was probably easier than changing them into mixed numbers, but you could have also done that. The third and final way to tell if two ratios are equal and therefore form a proportion is to find a common multiplier. A common multiplier means, can I do 2 times something to get 18? Yes, I can. Can I do 5 times that same thing to get 45? Yes, I can, and therefore they are equal. Okay, let's try over here. Well, 6 times 7 would be 42. But is 7 times 7 really equal to 53? No. That would be 49, and therefore, no, these do not form a proportion. So let's review. The 3 ways to tell if 2 ratios are equal and therefore form a proportion is, number 1, cross multiply, and this works with smallest numbers. See if they equal. If they do, it's a yes. If they don't, it's a no. Reduce, and this works with larger numbers. If both fractions reduce to the same smaller fraction, when they're all the way reduced, then yes, they form a proportion. If not, then no, they do not. And finally, find a common multiplier, and these you'll do automatically. We did some of these last week, so you'll already know. If 2 times something is 18, and the same thing we can multiply down here, then yes, they form a proportion. If not, then no, they do not. And I know you thought you were done, but on the back of your notes page, I want you to write this down. What if I give you 2 over 3 and I tell you these form a proportion and you have to say what x is over 15? Remember what to do about that? That's right, you are gonna, this is a common multiplier that you've been using and you just didn't know it was called that. If I know this times 5 equals this, then this times 5 has to equal this. So x equals 10 would be my answer. Let's say it's a little harder, because you're already good at those. What if I had 8 over question mark equals 4 over 15? Now we have to kind of go backwards because I need to go from here to my unknown. So I got to go the same direction up top. So I don't do divided by 4 or divided by 2. I have to do times 2 because 4 times 2 equals 8. Therefore 15 times 2 will give me my question mark. And we know 15 times 2 equals 30. Therefore, my unknown equals 30. What about one like this, where we have 5 over 3 equals 20 over our x, or our unknown? Again, if I have to go from this to this, then I have to think in this direction. If I multiply by 4 up here, I have to multiply by 4 down here, and therefore my question mark equals 12, because 3 times 4 equals 12.